Good day everyone. Today I will be demonstrating my modification to the mini lathe headstock spindle. As previously mentioned in my video number 13, the headstock spindle bearings are faulty and at the same time the gears are also damaged. So I have decided to go to the route of having just a single reduction in where I will be using a 62 HTD 5M pulley. The pulley is purchased from an online store. It originates from China, and the pulley is a flange pulley with a 15mm belt width. I have machined down the rear part of the pulley. You can see here, these are the set screw holes which I won't be using, and once I've machined down this flange section here, it's about if I'm not mistaken, it's about 7mm from here to here. Okay, and then this will act as a spacer. Okay, and then I've also machined a keyway here which will fit onto the spindle shaft. Okay, so this is the 60 tooth pulley which will sit here to spin the spindle. Okay, at the same time I'll be using a 15 tooth pulley, motor pulley. Diameter is 8mm, width is about 15mm, 15mm belt. Okay, it's 15 tooth. So this is 15 teeth plus and this is the spindle pulley. The tooth count is 60, so we'll give you a ratio of 4:1. Based on the original mini lathe, you can switch or can select between high and low range. The high range will give you approximately 1.9 ratio, overall ratio. Means the motor will spin at 1.9 times. That will translate the rotation of the spindle of about 1 time. And the lowest ratio will give you 4.4:1 based on the calculations. Okay, so the closest I can get is a 60 tooth spindle pulley and a 15 tooth motor pulley. So it gives me a ratio about roughly 4:1. That translates to about 1200 RPMs at maximum motor speed. Okay, then I've also machined a spacer. Okay, that will acts as a sealing area for the oil seal. Okay, but the front seal is 48mm ID. The OD is 58mm and the width is 8mm. So all of these retainers are custom made. I've turned them down on my other lathe. It's a C1 lathe to make this part. And then as I mentioned before, you can pump grease through this pot. It will pass through this hole, squirt out through this side, fill up this oil seal and lubricate the bearing adequately. Okay, so this modification will be substantial to allow me to lubricate the headstock adequately to keep the bearings well lubricated, and also at the same time protects from any swath from penetrating the unit. So if you can see here, this is with the retainer. Okay. At the same time, I'd like to mention that since I've removed the high and low selector, I have plugged the holes using an aluminium piece which I machined with a flange head. I just hammer it in. It just friction fit, but it's a very tight friction fit. Okay, and then just refurbish the entire unit. I sprayed black, and then I also machined another plug over here, and then I machined this profile to fit this retainer. Okay, and then I've done the same for the front over here. Okay, I've done the same with the front over here. Sorry, okay. So this will basically ensure there's no leakages, and also no dust or dirt will get into those holes. Performed assembly. Okay, as for the bearings, they are NTN brand tapered needle roller bearings. Okay, so these are the inner races. Okay, and then as for the outer race, I've pressed them into the headstock. Here's number 1 and here's number 2. Okay, so we are ready to. I've managed to press fit the front headstock tapered needle roller bearing inner race. It must fully sit against this flange. Don't forget to press fit your oil seal retainer here first. Okay, what I did is I didn't have a press available to me, so what I did is I froze this in the freezer, pack it in a plastic bag, froze it in the freezer to shrink the spindle slightly, and then I use a large thick PVC pipe that is sleeved around this spindle and hammer it in. Okay, what I've done, since I've having a single reduction unit, I machine a new keyway slot. From this point to here is about 25 millimeters, so the new key is here, which will slot in quite nicely over here. Okay, so the new key will sit here. Same time, the pulley will be pressed in, which will fit, which will be keyed to this key. So it will provide positive engagement. Okay, so let me do a rough assembly and show you how it all goes together. Okay, so this is the spindle. I need to rotate this. This is the front, because the oiling is towards this side. This is the former lever here. So what you do is slide it in. Okay, and this retainer, and the retainer needs to be pressed in as such. Okay, so you can see here, this is the oil seal with the retainer, greasing pot. So this is the rear part. I have another bearing which I will press in, another bearing here, which I'll fit it this way. Okay, I will press it in afterwards, just to demonstrate to you. Let me get it out first. Okay, temporary. Put it over here. Okay, then this sleeve will be pushed here. After I place the bearing, the sleeve will be pushed here. Okay, the oil seal and the retainer will push here, just to make it easy. Just for demonstration purpose, I'll press this in here. Okay, so it snugs, it fits like this. So it provides a lip for the sealing. Okay, so this will be pushed into the slot. Ensure this hole is aligned. Okay, it will sit at such. So you can see here, it's fully sealed. This pulley will sit this way. I designed it in such a way that this faces out. So I need to put in the key. Okay, as you can see here, the gap from the key. Pulley is slot in. Pulley is slot in accordingly. It will sit. Okay, the flange of the pulley will be approximately 1 to 1.5 millimeter from this face. Means this flange will be away from this face. Okay, this flange will be away from this face, approximately 1.5 millimeter, based on the measurements. I've done all the simulation on CAD. I will share the drawings later. Okay, so once this is done, then I need to put my 1 pulse per ref index wheel, okay, followed by the locking nut, and then the external tachometer index wheel is about 10 slots, original wheel, and then followed by the second locking nut. Okay, now since I'm using tapered roller bearings, I have to ensure the preload is correct. Okay, you can see a lot of videos performing the same task. They are very good videos that can tell you how much of preload, so it's a bit of a trial and error. Okay, once done, I can just remove these bolts, pump in some grease with a syringe. Okay, what grease I'm using at the moment is a molybdenum base grease. I'm using a Delphi grease at the moment. You can use any other brand. It's grey color, easy. Its viscosity is fairly light, and you can actually put it in a syringe and pump it in. Okay, so this will be my new headstock. Okay, and then the motor pulley will be somewhere here. Should be somewhere here. Okay, and then it will drive a belt. So I have to eliminate all the other accessories. Okay, and then later I'll make a new mount for my index signal and my tachometer. I will share that in the next video. Okay, thank you for watching. Take care.